In this video, I'm going to be going over logarithmic differentiation, so let's get into it. Logarithmic differentiation is a technique used to differentiate functions that are complicated. And you'll see what I mean by that, but basically it involves taking a natural log, which you'll see in just a minute, and that kind of helps us simplify the expression. So there are three cases where you'll use logarithmic differentiation. One case is if you have a product. So I'm not just talking a product like f times g. I'm talking like f of x times g of x times h of x, and maybe even more than that. Just a really complicated product that if you use the product rule, it would be like you'd have to call like this a of x, this other stuff b of x, and you'd have to use the product rule repeatedly, which is just kind of a headache. The other case where you need logarithmic differentiation is if you have a quotient. So like f of x over g of x, and these quotients themselves might even be pretty complicated. And then the final case where you would need it is if you have a power of functions, or functions raised to each other. What I mean by that is if you have something like f of x to the g of x, we know how to differentiate f of x to the n and n to the f of x, but we don't know how to differentiate this. Okay, so the way that logarithmic differentiation works is pretty much, it just really helps to simplify the expression using log properties. For example, if we do natural log of f of x times g of x times h of x, what's going to happen is because the natural log of a product is just a sum of natural logs, you're going to get natural log of f of x plus natural log of g of x plus natural log of h of x. And this is often a lot easier to differentiate. You would need the chain rule, but it's not as much of a headache as repeated product rule. For quotients, if you have the natural log of f of x over g of x, that's the same thing as the natural log of f of x minus the natural log of g of x. So logarithms turn division into subtraction. And for this other case, f of x to the g of x, the natural log of that, what you do is you bring this power down in front. So this would be g of x times natural log of f of x. And you would need the product rule here, but that's still a lot easier, and we actually know how to do this. So in short, logarithmic differentiation works by using properties of logarithms to simplify expressions. So let's go and look at the steps. Alright, so I think the best way to see this, like with implicit differentiation, is just with an example. So the example we have here is y equals x to the x. The first step is to take the natural log of both sides. Now, what we're going to do is we have this property of logarithms that if you have log of a to the b, that's the same thing as b log a. We're going to use that to simplify this natural log of x to the x. So on the left, it's going to stay the same, but on the right, we're going to have x natural log of x. So this is a little bit simplified because we actually know how to differentiate this. We would need the product rule, but we know how to differentiate x and we know how to differentiate natural log x. So this is easier to work with. The next step is to differentiate both sides with respect to x. We get the derivative of the natural log of y is equal to the derivative of x natural log x. So look at this. Use the chain rule to simplify d over dx of natural log y. What that means is because we have this function on the inside of the natural log, y is some function of x, we actually need the chain rule. We know that the chain rule says that we need to do the derivative of the outside evaluated at the inside times the derivative of the inside. Well, the derivative of natural log is just reciprocal, so 1 over, and then we replace that with the inside function, so 1 over y. And then the derivative of the inside is just dy dx, the derivative of y with respect to x. On the right, we need to use our product rule. So the product rule says that the derivative of f times g is equal to f prime g plus f g prime. Well, here our x is our f and natural log of x is our g. The derivative of x is just 1 times g, so natural log x, plus x times the derivative of g, which would be 1 over x. So this x and that 1 over x will cancel. So this is just going to be natural log x plus 1. Okay, so this is our expression so far. Remember, what we're trying to do here is find the derivative of the original function, which would be dy dx, the derivative of y with respect to x. So to do that, we can just multiply by y on each side to get rid of the 1 over y. But notice, we have, on this right side, we have this y. What is y? Well, if you recall, our function y is given by y equals x to the x. So we can just substitute that in. And what we'll get is that our derivative is, okay, so that is a pretty easy example. I went through it pretty slow just to make sure you see all the steps. But now let's do some practice that'll be a little more convoluted. Alright, so we're given that y is x to the fifth minus 10 cosine of x all times 5 to the x plus 10x minus the square root of x plus 2. And we want to know the derivative of that. Remember, the first step is just take the natural log of both sides. So we get natural log of y is equal to, okay, so we have a product here. So when we do the natural log, we can split up. Instead of having a product on the inside, we have a sum on the outside. So what that's going to look like is the natural log of x to the fifth minus 10 cosine of x plus the natural log of 5 to the x plus 10x minus the square root of x plus 2. So now we can take our derivative of both sides. Okay, so we can do this derivative separately. We can kind of distribute it to each of those terms. For this first term, the derivative of the natural log of x to the fifth minus 10 cosine x. Well, we have two separate functions kind of we can think about. On the inside, we have this inner function. We can call that f. We also have this outer function g. That's the natural log. Well, the chain rule says that the derivative of g of f is equal to g prime of f times f prime. Basically, the derivative of the outside, evaluated at the inside, times the derivative of the inside. Well, the derivative of the natural log of x is just 1 over x. So we're going to have 1 over the inside, so 1 over x to the fifth minus 10 cosine of x, times the derivative of whatever's on the inside. So that's going to be 5x to the 4, because we use our power rule. And then the derivative of cosine of x is minus sine of x. So this minus and then that minus from differentiating cosine is going to make a plus 10 sine x. So the minuses will cancel each other out. Alright, so this is just for this bit. What about for this bit? Well, it's going to be a similar process. The derivative of the natural log of 5 to the x plus 10x minus the square root of x plus 2. We're going to have a 1 over, because that's the derivative of natural log. So 1 over 5 to the x plus 10x minus the square root of x plus 2. And then times the derivative of the inside. The derivative of 5 to the x is 5 to the x times natural log 5. The derivative of 10x is just 10. And the derivative of minus square root of x plus 2. Let's just do the derivative of square root x plus 2. This is the same thing as the derivative of x plus 2 to the 1/2. From our power rule, we're going to have 1/2 x plus 2 to the negative 1/2. And the derivative of the inside is just 1, so we can ignore that. So we get 1 over 2 root x plus 2. So, and then we have a minus. So we'd have minus 1 over 2 square root of x plus 2. All right, let's clean this up a little bit. All right, so this is what we have so far. So it's a lot of algebra. It's probably the most algebra-tedious thing you'll have to do in Calc 1. Probably. I think it's close. All right, on the left, we have the derivative of the natural log of y. Well, that's going to be 1 over y times the derivative of y with respect to x. So this would be 1 over y times dy dx. So to get our final answer, we would just multiply by y on both sides. So let's write out our final answer using the fact that y is this. All right, this is our final derivative. As you can see, it's pretty complicated, and just overall, it's kind of a mess, really. That's kind of the gist with these problems. It definitely makes it easier because, you know, using the product rule for this, and or like even expanding this all out, it would be a lot of work. And this definitely makes it easier, even if it's a little more complicated looking. So let's move on to the next example. Alright, so we have that y equals x to the tangent of x multiplied by arctangent x minus e to the x. And we want to know what dy dx is. First step is to take the natural log of both sides. We'll have natural log y is equal to. So we have a natural log of a product, so we can turn that into a sum. So natural log of x to the tangent x plus natural log of arctangent x minus e to the x. This can be simplified even further. We can bring this tangent of x down. So we get tangent x natural log x plus the natural log of arctangent x minus e to the x. Now let's take the derivative of both sides with respect to x. Okay, so if we do these two parts separately, this part and this part, for the first part we're going to need the product rule. So the derivative of tangent of x, that is secant squared. So it's going to be secant squared x multiplied by natural log x plus tangent x times, what's the derivative of natural log x? That's just 1 over x, so divide by x. For the second bit, by the chain rule, we need to do 1 over, because that's derivative of natural log, the inside, multiplied by the derivative of whatever's on the inside. So what's the derivative of arctangent? If you recall, hopefully you have a formula sheet to make this easier for you. But if you don't, if you recall, the derivative of arctangent is 1 over 1 plus x squared. And then the derivative of negative e to the x is just negative e to the x. So if we put this all together, we'll get Okay, let's make a little bit of room. Alright, so for the derivative of the natural log of y, we know the derivative of the natural log x, which is the outside function, is just 1 over x. And then the derivative of the inside is just dy dx. So we do 1 over the inside, which is y, times the derivative of the inside, dy dx, is equal to all that business. So then let's just multiply both sides by y. And using our original definition for y, we get this. So as you can see, it's once again very complicated, which it's pretty much always going to be if your function is as complicated as this. Let's do one more example problem, and then we'll be done. Alright, for this one, same process. Natural log y is equal to the natural log of everything on the right. Notice we have a quotient, we're dividing, and that's going to turn to subtraction when we take the natural log. So we'll have natural log of x squared. And if you notice, we still have more we can simplify. We can turn these products on the inside of these logarithms to sums. So we'll have natural log of x squared. We can bring that 2 down. So we'll have 2 natural log x plus the natural log of e to the x plus 1 plus the natural log of root x minus 3 minus the natural log of x to the sine x. We can bring that sine x down, so minus sine x natural log x. And then we still have a minus, because this is all part of this one logarithm, minus the natural log of x to the 4th minus 2x. Okay, so now if we take a derivative, the derivative of natural log y is equal to, okay, let's just go one by one. For this first term, the derivative of 2 natural log x is just 2 over x. For the natural log of e to the x plus 1, we would have 1 over the inside, so 1 over e to the x plus 1, times the derivative of e to the x plus 1, which is just e to the x, because the constant goes away, plus, again, we have to do 1 over the inside of square root x minus 3, times the derivative of the inside. So the constant will go away when we differentiate. And the derivative of the square root of x, that's just x to the 1/2. So this is 1 over 2 times x to the minus 1/2. So that's 1 over 2 square root x. So I can bring this all to the denominator. So 2 square root x minus the derivative of sine x natural log x. That's going to be a product, so we need the product rule. The derivative of sine x is cosine x times natural log x. And then we have a plus sine x times the derivative of natural log x. That's sine x over x. And then we have one more term, the derivative of natural log of x to the 4th minus 2x. That's 1 over x to the 4th minus 2x. And then the derivative of the inside is just 4x cubed minus 2. Okay, let's simplify this. I'm going to distribute this. Alright, so remember, from the past examples, we have that the derivative of natural log y is 1 over y times dy dx. So then, to get rid of that 1 over y, we just multiply everything by y. So our final answer is going to be that our derivative is equal to all of this stuff times our original function. That's kind of the theme. You're always going to have to times by your original function in the end, which is this. Okay, so this is our derivative. It is incredibly, I don't even know the word for it. It's very complicated, and it's a mess. All right, we're all done with practice. Thank you for watching the video. I hope that you enjoyed it. In the next video, I'm going to start going over some of the applications of differentiation. So check that out. Anyways, in the meantime, just take care. Have a good day.